Matrices, we continue looking at this topic. Now, solving simultaneous linear equation using matrices. Remember, we looked at the matrices, addition and subtraction and multiplication of matrices, and we looked at the inverse matrix. Now, I'm going to discuss the general principles behind solving simultaneous linear equations using matrices. Then, later on, we look at a few examples. So, go here now. Suppose you have this matrix A, B, C, D. That is the matrix that we have here. Then what you have here is X multiplied by Y equals E and F. Suppose you multiply out these two matrices. You multiply these two matrices, you get row by column. This row, you have only one column here. See that? So, the first element in row 1, remember it's this row by this column. So, pay attention to that. First element in row 1 times X plus second element in row 1 times second element in the column. First in row 1 times the first in the column. Second in row 1 times the second in the column. You have A times X. Then plus B times Y. What is that equal to? Going to be equal to E. You see that? It's row 1 times the column, give you row 1 times the one column that you have. See? Next, you're going to have row 2 times the column. You have only one column there. First in row 2, multiply by the first in the column. Second in row 2 times the second in the column. So you have Cx plus Dy. You see that? So, here now, you have C times X plus D times Y equals F. Now look at that. That looks like two simultaneous equations, a pair of linear simultaneous equations. You have equation 1 and equation 2. See that? So, in this case, you would start with the simultaneous equation and you go this way. You write the simultaneous equations in matrix form. So these are the simultaneous equations. And this up here is the matrix form of the simultaneous equations. So, as I said, you would normally start with this. Then you have the matrix form. Remember, we're discussing the principles behind the solution for understanding. And when you understand the maths, it's easy to remember, it's easy to catch when you remember it, and it's more fun doing the maths. You enjoy it more. You enjoy solving the problems more. So you have A, B, C, D times have X, Y equals E, F. So, you know A, B, C, and D, E, and F, but you don't know X and Y. So you need to find out what is this matrix. So what you do, if you divide both sides by this matrix, remember you can't divide by a matrix directly, but we're doing that here just to explain the principle. If you divide this side by A, B, C, D, it cancels itself. You see that? That's on the left hand side. But you divide the right hand side also by A, B, C, D. So now, what you have is a case where A, B, C, D, the matrix, cancels itself. So, here, XY is equal to EF over A, B, C, D. Now, let us remember what happens in numbers. Suppose you have 10 multiplied by X equals 30. What you would have here, to find out what X is, you divide both sides by 10. 10 cancels 10. So you have X equals 30 divided by 10. Now this is the same thing as 30 times 1 over 10. You see that, remember? Which is 30 times 10 inverse. You can also have it as 1 divided by 10 times 30. Alright. So, this is 1 divided by 10 times 30, which is the same as 10 inverse times 30. So, applying the same argument to the matrix here, you have XY equals. Now that you have EF divided by ABCD is the same as the matrix EF times the inverse of ABCD. It's the same thing as saying the inverse of ABCD times EF. You see that? So after that, you multiply out the matrices. This one at the top here cannot be multiplied because you say E times A, you need something times C. So you cannot multiply with the matrix, the 2 by 1 matrix to the left and the 2 by 2 matrix to the right. But fortunately, you can multiply a 2 by 2 matrix by a 2 by 1 matrix. Suppose the inverse of ABCD was P. Suppose the inverse of ABCD was PQRS. And you multiply that by EF. What you would get is P times E plus A times F. It's other matrix. Then you would get R times E plus S times F. That is what you would have. And this will be equal to X, while this down here will be equal to Y. So that is the general principle. General because I'm using letters. I'm going to illustrate the principle by solving a pure simultaneous equation involving numbers. So that will be next video. I will see you then.